All right, welcome everybody. My name is Jennifer Fairbrother. I'm the Conservation Director at the Native Fish Society. Thank you all for joining us today for another Lunch and Learn series. Today we are featuring Maria Kuruvilla, who is our scholarship recipient for the 2022 Wild Fish for All Scholarship. And Maria will be chatting about her graduate research related to hatchery smolt releases and run timing in wild salmon. So to begin with, I just want to take a moment to share a little bit about the Wild Fish for All Scholarship, because we are opening up our next opportunity. People are now welcome to apply to be our 2023 scholar recipient. The Native Fish Society believes that supporting the diverse voices of everyone in the Northwest will help us build the groundswell for the revival of abundant wild fish in the region. And in order to elevate those diverse voices and break down barriers to racial and gender diversity in fisheries conservation, we created the Wild Fish for All Scholarship. And this is a scholarship that we offer once a year. It's a $1,000 academic scholarship to Black, Indigenous, people of color studying fisheries conservation, policy, or science. And I want to introduce really quick Peter Gray, who is the Vice President for Community Outreach and Conservation Education at the Tualatin Chapter of Trout Unlimited, to share some exciting news about what is a little different about our scholarship this year. So Peter?
Thank you very much. The Tualatin Valley Chapter of Trout Unlimited Board of Director agrees wholeheartedly with the Native Fish Society belief that supporting diverse voices does build a groundswell for the revival of abundant wild fish in the Pacific Northwest. And we share the desire to elevate these diverse voices and break down barriers to racial and gender diversity in fisheries conservation, consistency with our own Board of Directors statements regarding the commitment to sustain, embrace, and expand our own diversity, equity, and inclusion activities. This fits right in. Therefore, the board is very pleased to support an additional Wild Fish for All Graduate Studies Scholarship with the hope that it will help us meet our goal, as well as the goals nationally and personally for the individuals who have the scholarship, to engage diverse whole communities to ensure that robust populations of trout and salmon in particular, since we're Trout Unlimited, once again thrive in their native range. And I want to also mention that, as is the case with the Native Fish Society, the Trout Unlimited will provide free one-year memberships to all of the 5 top applicants to the scholarship program. Thank you.
Thank you so much, Peter. We are really grateful to the Tualatin Valley Chapter of Trout Unlimited for joining us and being able to double the impact of our Wild Fish for All Scholarship this year. So we will be offering 2 $1,000 academic scholarships this year. To be eligible, you need to identify as BIPOC, and we strongly encourage BIPOC women to apply. In order to apply, you can send a short essay, we say around 500 words, answering the question, why do wild native fish matter to you, your home waters, and your region? And then we also ask that you include 1 letter of recommendation from a person in your department or who is somehow working with you in your studies. You can email these materials to info@nativefishsociety.org with the subject line Wild Fish for All Scholarship Application. We'll be accepting applications through November 15th of this year. So please reach out if you have any questions. You can find the eligibility criteria and instructions for applying on our website, nativefishsociety.org. So with that, I am excited to introduce Maria, our 2022 Wild Fish for All Scholarship recipient. Maria grew up in Bangalore, India, and spent her summers at her grandparents' farm in a small state in the south of India. She studied physics, receiving her undergraduate degree from the University of Delhi and a master's in physics from Purdue. She is currently a graduate student at the University of Washington, where she studies in the Quantitative Ecology and Resource Management program. under Dr. Andrew Birdall in the School of Aquatics and Fisheries Sciences Department. Her research focuses on the collective behavior of fish to understand how they use social information to interact with their co-specifics, their environment, and their predators. So thank you so much, Maria, for joining us today, and I'll hand it over to you.
Thank you, Jennifer, for that introduction, and thank you all for being here. I am going to share my screen. Can you see it, Jennifer? Awesome.
Yes, we can see it.
Yep, everything's looking good.
Okay, so I'm actually excited about the discussion section for today after my presentation, because I'm sure all of you all know more about salmon than I do, and I'm looking forward to your suggestions on how to taking this project forward. So today I'm going to talk about the Pied Piper effect in salmon, which is the effect that hatchery salmon have on wild salmon migration timing in Washington. So I'm sure you all have heard about the children's story, The Pied Piper of Hamelin, where the Pied Piper sort of lures the children away from the town to danger with his pipe. Now, what is the Pied Piper effect in salmon? We are trying to find out whether the same phenomenon exists in salmon in the rivers in Washington. And in this case, in the case of salmon, the Pied Piper would be the large number of hatchery fish that are released into the rivers and that are migrating to the ocean. And the children in this case would be the wild fish that sort of see the large number of hatchery fish in the rivers and are sort of motivated to migrate along with them. So why should we care about the Pied Piper effect in salmon? So to explain that, I need to go into the background a little bit. So we know that Washington has 5 salmon species: Chinook, coho, chum, pink, and sockeye. Additionally, we have steelhead, bull trout, and cutthroat. And so all of these 8 salmonid species share an anadromous life cycle, which means after they hatch, they spend some time in the river in fresh water, and then they migrate out to the ocean where they feed, they become bigger, and then they return to their natal streams as adults to lay eggs. So in this whole process, they bring a lot of ocean nutrients inland, and they provide a large number of food for a variety of species, including humans, otters, bears, forest trees, and even like the fungal networks in soil benefit from this whole, from salmon. But even if you don't look at all the ecological benefits that salmon provide, we know that culturally and economically, they're very important to the Native Americans, as well as other people who've settled in the Pacific Northwest. But despite their importance, a lot of salmon populations in Washington have been listed as threatened or endangered under the US Endangered Species Act. And especially the salmon in the Puget Sound area are doing really, really badly. And there are a number of reasons for this decline of salmon numbers in Washington. And the main reason is sort of the large number of huge hydroelectric dam construction in this area. And that sort of changes the habitat from this river that you see on the right here to what we see now. And before I started working on salmon, I used to think that the large dams are sort of physically stopping the salmon from migrating upstream and laying their eggs. But now I know it's a little more complicated than that. So these large dams sort of change the river ecosystem in many ways. So they reduce the stream habitat complexity that salmon need to lay their eggs, to spawn and to feed and get protection from a lot of predators. And they change a rushing, flowing river into almost a series of lakes. And this has a lot of downstream effects, which is it changes the way the predators of salmon interact with the salmon, potentially making them more vulnerable to predation. So the construction of hydroelectric dam changes a lot of things in their habitat. And of course, we've also overfished their stocks, drastically reducing their numbers. And also logging affects, reduces their numbers greatly, because removing wood debris from the streams again decreases habitat complexity, stream complexity that they need for feeding and rearing salmon. And cutting rivers from the sides of the rivers increase water temperature. And that means that the salmon grow faster, but that also means that they migrate to the ocean faster and reach the ocean in like almost winter-like conditions. And some years are just have unsuitable ocean conditions for salmon, like El Nino years where they don't have enough food in the ocean. And along with climate change where water temperature is increasing and the food availability is different in the ocean. So when we put all of these things together in one given year, that's when salmon numbers decline drastically. So in response to this decline in salmon numbers, there were a lot of hatcheries, salmon and trout hatcheries that were set up throughout Washington. And their goals were to increase abundance for fishing, as well as to promote conservation of imperiled population. Now, hatcheries have a lot of economic and cultural benefits to this region, but they also pose a lot of risks. And the main ecological risk that hatcheries pose is that now there's a lot of competition between the hatchery and the wild salmon for fewer resources and lesser habitat. There are also genetic risks associated with hatcheries, which is that there's a loss of genetic diversity among and within wild salmon populations. And there's also loss of fitness because now we're selecting for traits that are beneficial for hatchery fish, but not necessarily beneficial for wild fish. And there's also a risk of overfishing. And it's also sort of like an excuse to keep degrading the environment that the wild fish need because we can just increase hatchery production. But despite all of this, hatcheries do support Washington's salmon fishery, and it wouldn't exist in the same scale as it does today if it wasn't for the hatcheries. And they're also used to fulfill the treaty rights of Native American Indian tribes. So the way I see it, the hatcheries are not going to go anywhere. So that's why I think we should sort of focus our efforts into hatchery reform and to enable better hatchery management, which is something we hope to do from this project as well. So what are the hatcheries doing? So our hatcheries artificially spawn and rear salmon in controlled environments where they're protected from the environment, they're protected from the predators, and then they are released into the rivers where they outmigrate to the ocean. So when they're in the rivers in freshwater, that's when they're potentially interacting with the wild fish. So apart from the indirect ecological interaction that they have with the wild fish, there's also a direct interaction that they have with wild fish in terms of social information. Now, when I say social information, I mean the information produced by other individuals due to their position, action, or interaction with their environment. And in this case, it would be the presence of hatchery fish in the rivers at the same time that would motivate the wild fish to migrate along with them. And there is already evidence of social information use in salmon. We know that salmon outmigrate to the ocean in schools and in large pulses, as opposed to continuously migrating out to the ocean. We also know that they group in the open ocean, as Maria and found out recently. And we also know that they use collective navigation techniques while migrating back from the ocean to the river to their natal sites. So with all of this evidence of social information use and also anecdotal evidence that of the Pied Piper effect, we think that the hatchery fish might be influencing the wild fish to migrate with them. So what is the Pied Piper hypothesis? So we hypothesize that large pulses of hatchery salmon smolts migrating downstream could motivate wild salmon to migrate with them, potentially causing them to migrate earlier than they normally would and over a shorter period of time at the seasonal timescale. And what does that mean? Early migration could mean less food in the ocean. When they reach the ocean early, the ocean's not as warm, it's not as productive, and so there's less food. But it could also mean that a fewer predators, the seals and the sea lions, haven't gotten there yet. But on a different time scale, hatchery salmon smolts could influence wild fish to migrate during the day, altering their migration time at the daily time scale. And what does that mean? Migration during the day could expose wild fish to more predation, but the abundance of hatchery fish could also swamp the predators and protecting the wild fish. So the data used for this project is a historical data set that's been collected for over more than 10 years. And they use small traps like the picture on the right over here, and they immerse it in the water twice a day for about 10 to 12 hours. And then they remove it from the water, and then they count all the fish that are trapped in it. They record the species, the age, the day, the time, and whether or not they're hatchery fish or wild fish. And this data has been collected from the state and by Tualatin tribe. So currently we have data from 6 rivers, which is Dungeness, Skagit, Green, White, Puyallup, and Nisqually. And 5 of those rivers, the hatchery is upstream of the smolts trap, which means that the trap is catching both hatchery fish and wild fish, and we can compare the 2 numbers. But in Nisqually, the hatchery is downstream of the trap, which means we're getting data of just the wild fish, potentially without the influence of the hatchery fish. And this could sort of be compared, could act like a control river, and we can compare what the wild fish are doing in Nisqually and what the wild fish are doing in all the other 5 rivers. So here's some data that I've compiled from the Dungeness River from years 2006 to 2014. So the top panel here is all wild fish, and the gray lines are the numbers for each year, and the orange line is just an average of all those years. The bottom panel is the number of hatchery fish going through the small traps. And immediately, like I said, you can see from the gray lines that the data is really spiky, whereas lots of fish are coming at a short amount of time, and then some days there are no fish. And you can also see from the wild fish data on the top panels that the outmigration time period for wild fish is protracted, and they migrate over a few months. Whereas in the hatchery fish data, you can see that there's usually one large spike for every year. And as soon as the hatchery fish are released, they outmigrate altogether to the ocean. And you can also see that there's significant overlap between the hatchery fish migration timing and the wild fish migration timing. You can see in the top left plot here, the Chinook have sort of a bimodal migration time. So some Chinook smolts migrate as soon as they hatch from their eggs, and some Chinook wait till summer to migrate out to the ocean. So to look at the correlation of the number of hatchery fish in the river to the deviation of wild fish from an average, this plot shows a deviation of wild fish as a function of number of hatchery fish. And you can see that there's some correlation where as the number of hatchery fish increases, the number of the deviation of wild fish from the mean also increases. But there's also a lot of wild fish that are migrating when there are no hatchery fish, as you can see from a lot of data points on the left over here. So in the model, I need to include other factors like time of year and temperature and flow of the river to sort of explain the phenomena that's happening, so that I can tease apart the effect that the hatchery fish have on the wild fish. I also looked at time of day of migration. So on the x-axis, I have hour of day, and on the y-axis, I have the proportion of fish that are migrating through the river. And in pink are the wild fish numbers, and in green are the hatchery fish numbers for first year Chinook, second year Chinook, coho, and steelhead. And you can see that both the wild fish and the hatchery fish are either migrating very, very early in the morning or in the evening, and not much during the day, which is probably good. And you can see the wild fish and the hatchery fish are sort of doing the same thing, except for the second-year Chinooks, in which that's the second plot over here, where you can see that the wild fish are actually migrating very early in the morning, but the hatchery fish are actually migrating in the evening. So it'll be interesting to see what is happening here and what's happening in the other species. So the challenges that I see and the next steps for this project would be to compile all these large data sets where each year and each river, there's sort of a different format. So I have to compile all of this data and also compile data for flow and temperature of the river into one large data set. And I think it's going to be difficult to find what the time scale of the Pied Piper effect is, because if the wild fish are sort of following the hatchery fish immediately or within a few hours, then I think I'll need a lot more statistical analysis to tease that effect out, because the smolt traps are only immersed in the water twice a day. I'll also need statistical analysis to tease apart different factors affecting migration time, such as temperature, flow, and just the time of the year. And interpreting the results and the survival outcome for wild fish is also important, because on one hand, wild fish may deviate from their optimal migration time because of the hatchery salmon. But on the other hand, migrating with a large number of hatchery fish may help wild salmon avoid predation by predator swamping. So what does this all mean for the survival outcome of wild fish? And sort of the goals of the Pied Piper project is sort of to figure out whether salmon smolts use social information. And I think the results could also aid in assessing wild smolt survival under different hatchery release scenarios. So I think the really exciting thing for me about this project is that on one hand, it's answering a really fundamental scientific question about social information use in salmon. But on the other hand, it's giving us results that we can use to enable better hatchery management. And I think the key to ensuring resilient salmon populations in the Pacific Northwest is to maximize the benefits of hatchery production for all stakeholders while reducing the risk to wild salmon. So I think that's one of the goals that we hope to achieve with this project. So with that, I want to thank all my collaborators. First, Andrew Bordahl, my advisor from UW, Tom Quinn, our collaborator from UW, Joe Anderson from WDFW, who's giving me all this data that I'm currently working with, Connie Okasaki, who's in my lab and also helping me with the statistical analysis, my program, UW Quantitative Ecology and Resource Management, my department, School of Environment and Fishery Sciences, and of course, Native Fish Society for inviting me for this talk. And with that, I'll take questions, thoughts, comments.
All right, well, thank you so much, Maria, for taking us through that. And it sounds like there's more to come. So I personally, and I'm guessing a lot of people on this call will be interested in seeing the outcome of your work and what you do end up, most likely publishing in the future. So please do keep in touch so that we can share that out with folks.
Definitely.
Why don't you go ahead or if folks want to unmute themselves and turn their videos on, that's your discretion. But if you have a question, please either raise your hand or let me know. While people are kind of getting settled, we had a few questions that came in before, so I can ask one of those. So let's start with this one. Would varied timing and different release points of hatchery smolts be cost effective, at least for short-term recovery until wild populations can sustain themselves? And I'm not sure. So I'll say, Maria, you're welcome to answer any questions you have knowledge of. If not, feel free to let us know. There are folks on this call from Native Fish Society that also can chime in.
Yeah, no, if anybody knows about this, I'm interested to hear the answer too. But as far as I know hatcheries have like sort of a predetermined date and time for when they release all of their fish. And I don't know what that is based off of. I think probably to maximize survival for their hatchery fish. And I'm not sure how cost effective, like how much, like what is the cost of changing that day and time by a few weeks. Yeah, so if anybody knows, I'm interested in hearing.
Yeah, I don't know about the cost effectiveness, but am I understanding that perhaps your analysis here could potentially be used to suggest kind of changes to release timings and locations that could then ideally be more beneficial for wild populations?
Yeah, if I'm seeing that it's the large number of hatchery fish over a short period of time is the one that's influencing the wild fish to migrate with them. Maybe hatcheries could release the fish over a large period of time, maybe just a little bit at a time, or maybe wait till the peak of the wild fish are done and then release them. Yeah, there are a lot of different hatchery release scenarios that could come up from the results of this project that the hatcheries could try.
Do we have any questions folks on the call want to ask themselves? If not, we can keep going with questions that have been asked in the chat and before the call. So Rachel asked in the chat, when we say overfishing, what do we mean? Recreational, commercial, and or First Nations? And what are their relative contribution to overfishing?
I've read a few papers, a few of them were from British Columbia, looking at both, I think, recreational and commercial fishing. And they did see that like the numbers were declining when there were basically no limits on how much fish you could catch. The numbers were declining. But I think the main thing to keep in mind is that we're throwing a lot of things at them. Dams and climate change and logging. And when all of these are combined is when we see like really huge losses.
Yeah, so in the kind of fisheries world, we talk about the 4 H's, though we're starting to talk about the 5th H of heat and climate change. So these are kind of the categories that Maria is referring to of like all of the things that impact salmon, steelhead, and other native populations. And like you said, Maria, it's kind of a death by 1,000 cuts, be it loss of habitat, heat from climate change, heat effect and flow effects from climate change, harvest, hatchery impacts that you detailed some of at the beginning of your talk. All of these things combine together to create difficult circumstances for wild fish in the Northwest these days. We had a couple questions that were related to the LWA. So I'll ask this of Maria, but also our Washington coordinator, Jay Michelle, is on the call. And so perhaps she can chime in as well. So one question asks, do you know the status of wild versus hatchery salmon in the Elwha River since the dam was removed? I heard that the tribes are populating the Elwha with hatchery salmon. Is this true?
I don't know. I know the wild fish are coming back, but maybe Jay Michelle can answer that. You're muted, Jay Michelle.
The last part of the question, can you repeat that, Jennifer? It broke up, I didn't hear.
So do you know the status of wild and hatchery salmon in the Elwha since the dam was removed?
Okay.
I've heard that the tribes are populating the Elwha with hatchery salmon. Is this true?
Okay, so yes, that is true. The Elwha tribe built a newer hatchery and started to put some salmonids back into the Elwha. I don't currently know the status of salmon overall, hatchery versus wild in the Elwha. I can share with you that there are many places you can look to find more up-to-date information on what's happening with the Elwha. We're paying close attention to one of those populations, which is the steelhead, and there's a very positive and very healthy return of summer wild steelhead to the Elwha. And there's a lot of research being done on them right now. And they're sort of using them as a indicator species, if you will, for other salmon that are returning. So we don't have all the, I don't have all the information right now, but I do know that that is a thing that continues to happen. And there are several resources I could put in the chat for folks who wanted to do some more looking into what is currently happening on the Elwha.
And then we had another kind of Elwha adjacent question while you're here, Jay Michelle, but this might be one for both of us. I hear about the return of big fish to the Elwha on the Olympic Peninsula. Are there other hotspots or big opportunities for rewilding?
Well, yes, they are. Thank you for asking. So we here in Washington State, if folks don't know, or I can briefly remind that we have a gene bank project happening that's state run. So WDFW picked 7 streams that they agreed they would not put hatchery stock of steelhead into. We would help rewild those streams and sort of do over time track the returns and see if that increased, decreased, or remained the same. So that's sort of the overall project. Real quickly, I will highlight that up on the Olympic Peninsula, the Sole Duck, my favorite river almost, is one of those gene bank streams. So that's one of the things that we want to pay attention to as we move forward. But Maria, I didn't mean to speak before you. Did you have anything to add?
No, yeah, I'm curious to hear from you.
Yeah, and I think there are lots of opportunities around the Northwest. It's something that Native Fish Society and a lot of other conservation organizations are focused on. Yeah, I think we see a lot of opportunity, especially for coastal streams. Most of them, not all of them, but most of them do not have major dams on them. So fish do have access to their historic headwater habitats. However, a lot of those systems have heavily been impacted by habitat degradation, particularly as Maria pointed out, logging in the Pacific Northwest coast ranges has had a real big impact on water quality, habitat for spawning and rearing, and generally increasing water temperatures and decreasing flows. But there is a lot of work going on around the region in those areas. There's also, there's opportunities all over. So if you're interested in a particular region and getting involved, please reach out to us. We have staff around the Northwest that are working on watersheds and what we can do to help reduce those factors that we previously talked about that are limiting wild fish. Do we have any other questions, discussion around Maria's presentation? I appreciate, Maria, that you left up your charts so that we can take a look at those. And if anyone has questions. Oh, Peter, it looks like you've got a hand up.
Yes, I just wanted to mention 2 things I put in the chat. One, that Trout Unlimited has a very long history with working with hatcheries to ensure that they're responsibly managed. So I have that link to the TU national website that may be interesting. You may or may not know about TU's involvement, but we've certainly done that all over the country. And so that's one thing, that resource that you may find interesting. And the second one, to your point just now, is the Salmon Superhighway, which is specifically working with the coastal communities so that they can mitigate some of those environmental, whether they're culverts that don't allow fish passage, or perhaps logging that is degraded, or just working with the local communities to help them become aware of it. So those are 2 things that Trout Unlimited is doing along the same lines that we've been talking about today.
Thanks, Peter. Don't see any other hands up, but please just call out if you do have a question. I guess, Maria, one question I have is, a lot of the places where we've been working some of the reintroduction programs, so this is places where anadromous fish, particularly salmon and steelhead, have been extirpated, usually due to dams, are now being reintroduced. And because they were previously extirpated, they have reintroduction hatchery programs. And one of the release strategies that we see a lot of these programs moving to is a volitional release strategy, where they essentially open the gates at the hatchery and let the fish decide when they want to leave.
Yeah.
Is this, how do you see that as like kind of being part of what you're trying to untangle here and maybe a possible hatchery reform, especially for these reintroduction programs to help those fish survive in rewild areas?
Yeah, I have also heard about that release strategy, and it definitely seems more like the natural what the wild fish are doing, right? It's a protracted outmigration period over a long period of time. So it'll be interesting to see whether the hatchery fish also are doing the same thing. Will they if they're not sort of forced out, will they also migrate over a long period of time? And I think the advantage of that would be, like I said, there are many things going on in the ocean, right? And on one hand, going very early, they might not get enough food and the ocean might not be warm enough for them. But on the other hand, they might avoid predators. So there are a lot of complicated things going on in the ocean and like what's waiting for them out there. So I think it's a good way to sort of not put all your eggs in one basket, like having like a large or protracted out migration time.
And when you talk about in your presentation trying to assess survival, are you talking about to the ocean or returning from the ocean? What is the kind of like, how are you going to quantify survival to determine, are some of these strategies better for the fish than other strategies?
I think both, yes. Survival in the ocean, which sort of means like, are they returning? Have they survived the whole sort of journey? And that it's not like we have the data to answer that. That would be more of doing a literature survey and seeing. So when they migrate 2 weeks earlier, and these are the ocean conditions, what is their survival going to be? When they migrate later, what is their survival going to be? And yeah, sort of looking at the existing literature and trying to determine what their survival outcome for wild fish are.
All right, well, that's all the questions I have and all the questions that have been asked before the presentation and in the chat box. So I want to give everyone one last chance if anyone has a question they'd like to ask Maria. Well, thank you, Maria, for being here today. And thank you for everyone that joined us to listen to this presentation. I hope that you will share with folks the information about our Wild Fish for All Scholarship opportunity, which is happening now for our next round. We'll have 2 recipients this year, thanks to the Tualatin Valley chapter of Trout Unlimited. Thank you, Peter, for coming today and sharing Trout Unlimited support for the scholarship this year. And this recording will be posted online, and I'll share it out to anyone who registered for the presentation today. So you can check your inboxes for that soon. And with that, I will say thank you and hope everyone has a great afternoon. Thank you, Maria.
Thank you.
Thank you very much.